At the end of this lesson, the student should be able to one, state the relationship between frequency, wavelength, and speed v. Two, solve simple problem based on the formula v equal to lambda f. See you in the lesson. Today we'll be looking at the relationship between frequency, wavelength, and velocity. Generally, these three properties control a progressive wave. And we could recall that velocity v is given by distance over time, or we can refer to it as what? Velocity is displacement. Displacement over what? Time. But however, we have here that we can replace this as velocity v is equal to wavelength lambda over period t. So we can write this in symbol that v is equal to what? V is given by lambda over t. Of course, we know that t is related to frequency. We have that f is equal to what? 1 over t. Also, t is given by 1 over f. Now from here, we can replace t here, which stands for period, with t equal to 1 over f. So we can rewrite this expression. So we can then have that v is equal to what? Lambda over 1 over t. 1 over f, not 1 over t. Now let me have then we have that v is equal to lambda divided by 1 over f. So we can then have that v equal to what? Lambda times, and the division becoming times, there will be fraction f over 1. So we are having our v is equal to what? Lambda f. Now generally we see that v equal to lambda f is an expression for calculating simple problem based on a progressive wave. And you have relationship between frequency, wavelength, lambda, and velocity v. We can take example as we are written on the board. Now this worked example. Let's take this problem to explain this formula. V equal to what? Lambda f. Where v is velocity, this symbol lambda is wavelength, and f is what? Frequency. Now, the example on the board here, we have a radio station broadcast at a frequency of 600 kilohertz. If the speed of light in air is 3 times 10 raised to 8 meters per second, calculate the wavelength of the radio wave. Now, how do we solve this simple problem? Using v equals to what? Lambda f. Now, let's see how we solve it. Solution. Now, first of all, we bring out the parameter. We are told that a radio station broadcasts at a frequency of 600 kilohertz. So write f equal to 600 kilohertz. Then if the speed of light in air, v equals to what? In air is 3 times 10 raised to 8 meter per second. We are asked to calculate the wavelength of the radio wave. So wavelength lambda is not given. So again, we write our formula V equal to lambda F. V equal to what? Lambda F. So from here, we see that the SI unit, now when you look at the parameter, we see that the SI unit of frequency is not kilohertz. So here, first of all, we'll take the frequency. Here is the frequency F is equal to what? 600 kilohertz, which means that 1 kilometer is equal to 1000 hertz. So 1 kilohertz is equal to what? 1000 hertz. So 1 kilohertz is equal to what? 1000 what? Hertz. So therefore we have that F is equal to what? 600 times 1000. So all in what? Hertz. So that will give us 600,000 hertz. So that will give us 600,000 hertz. So we've got the value for F. Then V is there. So we substitute into the expression V equals to lambda F. So we have F, V, we have V equal to, for lambda, now, recall we are asked to find what? The lambda. We are asked to what? Find the lambda. So there are two ways to do it. Either you substitute these values of V equal to 3 times 10 per 8 meter per second for V, and also F equals to 6,000 hertz for F, or you directly make lambda the subject of the formula, since we are interested in lambda. So we have V equal to lambda F. So we divide both sides by F. We have V over F equal to what? Lambda F over F. So F will cancel out F. The other lambda is equal to what? V over F. So we can substitute that lambda is equal to, for V, recall we have 3 times 10 raised by 8, 3 times 10 raised by what? 8. And also all over 600,000. Then we can write that lambda is equal to 3. 10 raised by 8 means what? 10 zeros. You can write 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. All over 600,000. So we can resolve this, that 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we are left with lambda is equal to 3,000 over 6. So lambda is equal to what? 500. So 3,000 divided by 6, that's 500. So remember, lambda, which is wavelength, the SI unit is what? Meter. So you add it meter. So that is the answer to the wavelength. So you have to calculate the wavelength of the radio wave. So the wavelength of the radio wave is what? 500 meter. So that is it. So we stop there for this section. Thanks. In the lesson ahead, please be prepared to leave in the comment section questions and state area of difficulty. Looking forward to see you there.